All right. So welcome back to this boring class. Boring because this is just at the time when we have Christmas and holidays starting. So we'll try to keep it a little lighter today so that you guys still continue with your feel for Christmas. All right, so Anshu has also joined. So all of you who can turn on the videos, I would request you to keep your videos on because that connects me better with you guys. If you are not video ready, if you think that flashing your video is going to be a little discomforting, it's okay. All right. So what we are going to do today is we are going to deal with quadratic equations and relate that with our understanding of parabolas, because again it might be an understatement from my side, but I feel that when you look at SAT preparation as a whole, the most interesting or somewhat difficult part is parabola or quadratic equation. If you have understood it, if you have nailed it, if you are comfortable with parabolas and the quadratic equations, your journey for SAT becomes much easier. So that's what we'll do. Okay, so let me do a quick roll call and see who all are here, and then we will get started. So we have Ananya, we have Anshu, we have Aryan, Dhanushri, Chris, Neil, Rehan, Sarah, Sivatsav and Vihan. And essentially the way I look at it is, these are the kids who have not started their Christmas break yet. That's why you guys are here. So just an announcement for you all, we will not have class tomorrow and the weekend following that. So we'll come back again next year, resume our classes from 4th of January. So let's deal with the quadratic equations real quick. So when we talk about any quadratic equation, we all know that when we have an equation, something like this is called a quadratic equation. The primary reason being the maximum power to the variable is 2. Okay? If it is not 2, it will not be called a quadratic equation. If it is 1, that becomes a linear equation. It becomes maximum power. See, here maximum power is 2. Here maximum power is 1, and here you can assume this as x to the power 0. That's how it becomes now. So the maximum power to the variable is 2. That's why it's a quadratic equation. If I am talking about an equation like this, this is not a quadratic equation. It's a cubic equation because the maximum power to the variable is 3. Okay? So that's our first criteria for qualifying something to be called as a quadratic equation or not. Now, when you deal with a quadratic equation, what is that we are trying to do? If you recall, when we talked about any equation like this where the maximum power is 1, it's a linear equation, and this helps us plot a straight line. Meaning, if you look at plotting this linear equation on a graph paper, it plots a straight line. And what essentially that means is each and every point on this line gives you a possible combination of x and y. Now, when you're dealing with quadratic equation, what you would have seen is, or observed is, you're not talking about 2 variables, we are only talking about only 1 variable, which is x. So when you're dealing with a quadratic equation, you're essentially trying to solve this equation to get the possible values of x. That's our ultimate goal. Everybody with me? And would you guys remember or recall how many possible values, or what is the maximum number of solutions that you can get from a quadratic equation? It's 2, maximum 2. Okay. Now we have dealt with quadratic equations. I think we talked about what are the three options or three possible ways to solve a quadratic equations, right? Let's say if I have a quadratic equation like this, there are three ways you can solve it. First way is when you try mapping it with one of the standard formulas of a plus b whole square, a minus b whole square, and a square minus b square. And essentially what you're trying to do is, you're trying to factorize this. You're trying to convert this into two factors. Something as a times b equals 0, and then that gives you two possible answers. Second option was, if you're not able to map it with one of the standard formulas, then second option is you go into that option of a into c, a plus c. Meaning you look at you compare your quadratic equation with the standard form and find out the value of a, b and c, and then you go for this option a into c, a plus c. Meaning you look at this and this, multiply them, meaning here a is 1 and c is 21, so multiply a and c, and then you look at a and c, which is 1 into 21, and then you look at what are the possible factors of this. And so here you have only two options I think, and you see which two factors combined together gives you a b. That was the second approach. And if that also doesn't work, then you have a third option. This is where you say, okay fine, I don't care about any other option, I will simply use my magical formula, which is minus b plus minus b squared minus 4ac divided by 2a, and this is called the discriminant, which determines how you will go about solving it. If the value of this b squared minus 4ac is greater than 0, you have two answers, two solutions. If this is equal to 0, then you have only one answer or one solution, and if this is negative, that is when you say that this is an impossible solution, meaning you cannot solve it. Do you guys remember all that, or you want to practice more? Everybody remembers that, right? Okay, before I go on, let's try solving this. Let's see who can solve this quickly. Let's try solving it, and then I'll go on to the agenda of this class. I'm assuming everybody is trying. I'll give you guys just 5 minutes, okay? Let's see. Who doesn't know how to solve it? And that's okay, not knowing is not a problem. I'm anyway going to solve it using all the three methods that I talked about. Rehan, do you remember how to solve it, beta? You're trying? Okay. Anshu, would you be able to give it a shot?
I'm doing it right now. Almost done. Just one more second.
Okay. Sarah, Neil, Srivatsa, everybody is trying, right? Aryan?
Yeah.
Okay.
Yes, sir.
Okay. Yes, Chris.
So I think I'm getting a negative discriminant, which means there's no real solution, there's two imaginary solutions.
Okay. You are getting imaginary solutions. Okay. Yes, Aryan.
I got the same thing, sir.
You are also getting imaginary solution. Okay, wonderful.
Yeah, because of the negative like square root.
Anshu, any second thought?
I got like an answer. I also got like I in my answer, like the imaginary.
Okay, you have gone one level further actually. Okay.
Yeah. Do you want me to say what I got?
Yep, why not?
Okay, I got -3 plus or minus 2 root 3i.
Root 3i. Okay. All right. Okay, so we'll probably just park it here. All of you who have done it or who are still doing it, you can probably look at the approach and then just cross verify that with your solution or your approach. So when I'm trying to solve it, this is what I will do. I'll just look at, okay, x square plus 6x plus 21. Is 21 my constant a square of something? No, it is not a square of something. So I cannot really map it with those standard formulas of a plus b whole square, a minus b whole square, or a square minus b square. That's my first thing ruled out. Now second thing is, now let's look at a and c. So a is 1, a is 1 and c is 21. So a into c gives me 21 into 1, which is 21. And what are the factors from this? 1 and 21, 3 and 7. These are two factors only. Now, whatever circus drama I do with these combination of numbers, I'm not getting a 6. Okay? 21 plus minus 1 gives me 20 or 22. 3 and 7 plus minus gives me 10 or 4. Nowhere close to this. Second option is also ruled out. Then I'm only left with the third option, which is my magical formula of solving x as minus b plus minus b square minus 4ac divided by 2a. So minus my b is 6, so minus 6 plus minus b square minus 4ac. B square is 6 square, which is 36, minus 4 into a into c divided by 2 into a. So this is minus 6 plus minus 36 minus 84. Yes, by 2. So minus 6 plus minus 36 minus 84 is 48. So minus 48 divided by 2. So here you got a negative. Minus, so minus square root of 48. What you can do is, minus square root of 48. So when you get a square root of a negative number, that's called an imaginary number. Okay, so you will simply say that I will not get any real solution for this one. I can only get imaginary solution for this one. Okay, or you can simply deny and say that okay, I cannot get any meaningful solution from this one. Okay, so that is the first thing. Now, what Anshu was doing was, he was saying, okay, fine. There is another concept of imaginary number. Okay, so minus 1 square root is given a name, I. Okay, so here, what you want to do is, you can say minus 48 as minus 1 into 48. Okay, so you can take minus 1 square root, minus 1 square root out, and 48. Okay, so this minus 1 square root is nothing but I into 48. 48 is nothing but 4 times 12. So 2 times 12. So basically, you can play with this one and you can put this answer in the form of an imaginary number. But if you don't want to go that route, or if you're not being asked to solve it with an imaginary number, you can just stop here and say that since my discriminant is giving a square root of a negative number, so there is no real solution for this one. That is where you will stop. Now, this was with the quadratic equation that we have dealt with. Now let's go to the next step. Here we were just saying that just a quadratic equation. Now I don't like 0. I just put a y here. This quadratic equation now has transformed into equation for parabola. Is that how you pronounce it? Parabola. So see, I have a very strong Indian accent, right? So I have grown up calling this parabola. Now when I hear you guys more, I call it parabola. But I might be wrong. But this is a parabola. When you have a quadratic equation on one side and a y on other side, this represents a parabola. Okay. Now it might look fancy that okay, I'm trying to complicate these things for you guys, which is not the case. It's nothing but a simple equation, a quadratic equation where you have two variables now, x and y. So far we were dealing with only x and giving this value as 0, and then we were trying to solve it for x. Now when you have two variables, it is going to become a parabola. And same thing you will do if you have to figure out how does a parabola look like. Okay, let it be like this. You'll simply draw a table, x and y combination. Let's say when x is 0, what is the corresponding value of y? When x is 0, this whole thing becomes 0, y is 21. When x is 1, what is the value of this? 1 plus 6, 7 plus 21, 28. When x is minus 1, it becomes 1 minus 6, that is minus 5 plus 21, 16. When x is minus 2, so it becomes 4 minus 12, which is minus 8 plus 12, 13. When x is 2, then it's 4 plus 6, 10 plus 21, 31. So when you try plotting this on a coordinate plane, I will say 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, and here I will use a bigger scale, 5, 10, 15, 20, 25 maybe, okay, or 6, 12, 18, 24, 30, minus 6, minus 12, minus 18, 1, 2, 3, 4, 5, okay. Now if you try plotting this, when x is 0, y is 21. So when x is 0, y is 21. So you're essentially talking about a point somewhere here. When x is 1, it's 21. So it's when it's 1, it's 21. 28. Sorry, 28, my bad. When x is 2, it's 31. So it's somewhere here. Now when x is minus 1, it's 16. So it's somewhere here. It's here. When x is minus 2, it's 13. Minus 2, it's 13. Somewhere here. So essentially, I could have used some few more points to make it look like a parabola. It looks like a parabola now. Okay. So this curve that you see, which is open on one end and closed on the other end, this is called a parabola, as you all would know. Now, my intention was not to just draw a parabola for you guys. Now we wanted to look at the equation of a parabola to get some insight from it. So now, when you look at, let's say, let's look at an equation for a parabola. Y equals, let's say, 2x squared plus 4x minus 8. Okay. Equation of a parabola also you can relate that with a standard form. Okay. This side of the x side of things. Okay. Y on the other side. You can relate that with this one. Now, when we were trying to plot x squared plus 2x plus 8 plus 21 equal to y, what did we see? It was a parabola that was facing upward. So that is the first interpretation. Meaning, if your value of x is positive, meaning not value of x, the coefficient of x is positive or it is greater than 0, you will see the parabola is facing upward. If you want to play around with that, you can put an equation saying x squared plus 2. Let's pick up a simple one. And then you put the table and see what is the value of x and y. Let's pick 4 values or 5 values, maybe 0, 1, 2, minus 1, minus 2. Okay. When x is 0, this is 2. When x is 1, this is 3. When x is 2, it is 4 plus 2, 6. When x is minus 1, it is again 3. When x is minus 2, it is 4 plus 2, 6. So 0, 2, you are talking about 0 and 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Okay. So 0 and 2 is here. This is your first point. 1 and 3 is here. 2 and 6, somewhere here. Okay. Minus 1 and 3. Minus 1 and 3. What happened here? This one is proving me wrong.
Negative x. Okay, so that'd be 1 plus 1 would be 1, not 3. Negative 1 to the power 2 will get you 1. That's negative 1 plus 2. So 2 minus 1 would be 3, would be 1, not 3, right?
Negative 1 will give me minus 1 squared. It's nothing but 1 plus 2, 3.
And then there's a negative x
There is no negative x here.
in that equation.
No, this x squared plus 2. That's it.
Once you do x, so it's negative 1 times x to the power 2. You do the exponent first and then multiply, right?
Oh, my bad. Now I get what wrong I was doing. So, yeah. So when it is 1, it is 3. So it is 1. Okay, it's 1 is okay. My bad. I was grossly wrong with my calculation. Thanks for waking me up. I was half asleep. Yeah. Thanks for it. That's what I was wondering. The basic concept has gone wrong. So when x is 0, this is 0. 0 minus 0 plus 2 is 2. When x is 1, so it's 1 squared and minus of that. So which is minus 1 plus 2. It gives you 1. When x is 2, it becomes 4 squared, negative of 4. So that is minus 4 plus 2. That is 2. Minus 2. And then when I have x equals minus 1, it becomes 1 squared. So when it's minus 1, again 1. And when minus 2, it again becomes the same thing as minus 2. So yeah, thank you. I don't know why I was making that mistake. So 0 and 2 is my first point. 1 and 1 is my second point. 2 and minus 2. 2 and minus 2 is my third point. Here again, minus 1 and 1 is this point. Okay. So again, when you look at this, so what happens is when your coefficient of x squared or the value of a, when you compare that with the standard form of the quadratic equation, you will see that when a is positive, the parabola is facing upward. When a is negative, it is facing downward. Is that clear to all of us, or you guys are as confused as I was when I was doing a square of this in a very stupid way? Are you guys clear? So basically now if you look at the equation of a parabola, this coefficient determines the first thing, which is whether the parabola is facing upward or is facing downward. Is that part clear to you guys? No response?
Yes.
Okay. Now let's dig through this a little bit more. Now this is one form in which you say I have a quadratic equation representing a parabola where I have x and y both the values, and then if I just see the coefficient of x, that tells me whether my parabola is facing upward, is like this, or is facing downward, and that is again depending on what is the coefficient. If this is greater than 0, this is the scenario. If this is less than 0, something like this, or even this, if it's a negative value, meaning less than 0, this will face downward. So that's the first interpretation. Now, what are the other things about the parabola that we need to know? If we talk about a parabola, this one, yeah.
The vertex and line of symmetry.
Yeah, vertex, line of symmetry, and the zeros, meaning where the parabola is touching the x-axis. When you say, what are the zeros of a parabola? Meaning, when this equation, the quadratic equation will give you an outcome as 0. That's what is called zeros of a parabola. Meaning, when the value of y equals 0, that is what will be your zeros of a parabola. Meaning, you will be left with the quadratic equation, you have to solve it for x and y, and all the values of x that you get, that tells you the points where the parabola is touching the x-axis. So now if you relate that with what we were doing with the quadratic equation before, if you get a solution, if you get one solution, let's say, that means that touches just at one place on the x-axis. If you get no solution for this one, meaning there is no 0, meaning there is no point on the parabola where y equals 0. That means parabola is lying somewhere here. It's not touching the x-axis anywhere. So be it an imaginary solution or be it a solution where you're not able to solve this equation, your simple interpretation would be the parabola is not touching the x-axis. That means there is no zeros for a parabola. So just by looking at a problem, if you have to figure out whether the parabola touches the x-axis or not, that will determine by using your knowledge and experience with the quadratic equation. 0 meaning where it touches the x-axis, meaning the y value is 0, and that is how you will solve it and get that. Now comes a vertex. How do you find out the vertex of the parabola?
Negative b divided by 2a over the discriminant is 0.
So there's another way of doing it actually, which I did not teach in the previous classes. So when you have a quadratic equation or an equation for a parabola, you can write the equation of a parabola in 3 ways. One is called the vertex form, one is called the standard form, and third is called the factor form. So, okay, are you guys with me so far, or I'm just running through with my own understanding of things? Are you guys able to follow me so far, or?
Yes, sir.
Okay. Okay.
Yes.
Okay. All right. So now tell me who knows about all these 3 forms and who has not come across this before. You know about it? Okay. Anybody on the screen? If you have heard about all the 3 forms or you have not heard about all the 3 forms.
I've heard about all of them.
Okay.
Yeah.
You also heard about it, Rehan?
Yeah.
Okay. How about you, Rehan, Aryan, Dhanushri?
Yes, sir.
You have heard about it? Okay.
Yeah, I understand.
Okay. Alright. Ananya, Sivatsav, have you heard about the 3 forms of equation of parabola?
I think I
with them too.
Okay.
Oh, maybe I forgot them.
Okay. So let's look at it. If I have equation of parabola like, let's say, x squared plus 4x plus 3. This is the most basic or the standard form, where you can relate this part with your standard form of a quadratic equation. Now, the second one is called factor form, which is nothing different from this. When you have a quadratic equation, I'm just making it up, okay? If this is the case, I'll say this will probably convert into x minus 3, okay, x plus 3 into x plus 1. I'm not making it up, I calculated it actually. Okay? This same quadratic equation can become like this. So this is called the factor form. Okay? And you can also write this same equation in the third form, which is called a vertex form. And we'll just transform all this same equation to 3 different forms, and then we'll see what is the use of that. How does it actually help? So now, third form would be x squared plus 4x plus 4. I made 3 as 4, so I will say plus 4, so plus 3 and minus 4. Yeah. So this becomes x plus 2 squared minus 1. This form is called the vertex form. Okay. So now you will say, how does it actually help? Why are we actually wasting time to learn 3 different forms wherein one form is enough? What even spend that effort? Yeah.
It's easier to find certain things with a factor form. You
Mhm.
can easily find the zeros of x.
Mm-hmm.
Vertex, you can easily find the vertex of x.
Yes. So now coming back to your point, right? When you were trying to use a formula for finding the vertex, you can simply convert this equation into the vertex form, and it will help you find out the vertex very quickly. So now there are 3 forms. So now look at this one. This is a standard quadratic equation. You will solve it, find out zeros. So if you have to find out where this parabola touches the x-axis, meaning where the value of y coordinate is 0. So when this is 0, and then you have this equation to solve, and you'll find out the values. Okay. That tells you that okay, there are 2 points where it touches the x-axis. Now, when you have this factor form, this makes your life much easier to find out the zeros. Because if you have the equation in the factor form, that means when you have to say where it touches 0, where it touches the x-axis, or where is the 0 of the parabola, you'll simply say this, and by looking at this equation itself, you immediately know that okay, either my x value is minus 3 here, and here it's minus 1. So it touches at minus 1 and minus 3. Okay. So the factor form makes your life much easier when you have to find out the zeros. Now, the vertex form tells you how to find out the coordinates of the vertex, the lowest point or the highest point. Yeah. Now, when you have the equation, equation of parabola in this form, here, if let's say if you just look at the equation, and here you see that okay, my a value, the coefficient of x squared is a positive value, meaning my parabola is facing upward. That means my vertex will be the lowest point, right? Now, if you have to find out the vertex, meaning the coordinates of the vertex, you know that your vertex is the lowest point in the parabola, meaning where the y value is the lowest. When will y value be the lowest? If you just look at this equation, when this whole thing is 0,
Y value would be
the lowest. Because if this value is positive, see, whatever be the outcome of x plus 2, be it a negative, be it a positive, the square of that will always be positive. So if you have to find out the lowest value of y, the lowest possible value of y is this becoming 0. Okay? So if this becomes 0, then only you are getting the smallest value of this. Otherwise, let's say if let's say x plus 2 is minus 7, this becomes 7 squared, minus 7 squared, 49 minus 8, 1, 48, a high value. If let's say x plus 2 is 3, this becomes 3 into 3, 9 minus 8, 9 minus 1, sorry, 9 minus 1, 8, which is still a higher value. When this part becomes 0, that is when you are getting the lowest value of y. So this tells you that okay, if you have your equation in the vertex form, your vertex, the lowest value of y will be the point when your this part is 0, meaning your x plus 2 is 0. So that when this is 0, you know that value of x is minus 2. So you usually got the x coordinate of the vertex. You don't have to do that calculation of b minus b plus minus b square minus 4ac. That may or may not be the right solution also. Okay. Now, once you got the x coordinate, you can just put that in this equation and you find out the y value of it. So when you put x equals to minus 2 in this equation, this part becomes 0, y is minus 1. So that is why you have 3 different forms of the equation of a parabola to cater to 3 different requirements. When you just have a standard form, you deal with it like a quadratic equation and you can find the zeros. You can figure out whether it's a upward facing a parabola or a downward facing parabola, and then you can find out where it touches the x-axis, which is the zeros. But when you have that in the factor form, finding out the zeros of the parabola is much easier. When you convert that to a vertex form, you can always find out the vertex coordinates of the vertex much easily. Are you guys with me so far?
Yes, sir.
Okay. Now let's play with this. And I'll be making up the question. Okay, it's not a question coming from anywhere. We will try practicing one problem to see all the concepts that we have learned, how we can use to determine the desired output. Let's say if I have an equation of parabola as minus x squared plus 2x plus 3. Okay. I will say if I move the vertex by 3 points, 3 positive points on x-axis and y, so x-axis 3 points and y-axis by 1 point. Find out the new equation of the parabola. So this parabola will, let's say, plot, this equation will plot, let's say this will face it downward. So this is making this. Now I'm saying I want to move the vertex of this parabola, meaning I'm shifting the parabola such that the vertex shifts in the x direction by 3 points, and then the vertex shifts in the y direction by 1 point. So I'm shifting the parabola to this place now. I want you guys to use your understanding of all that we have learned so far to find out what will be the new equation if you have to move your parabola by this. This might sound like a difficult problem, but this is not difficult. This is an interesting problem actually. You have to apply your understanding and then find out the new equation. Everybody understood this question, right? I'm repeating myself. I have a parabola with this equation, y equal to minus x squared plus 2x plus 3. I want to shift the vertex, or I want to move the parabola such that the vertex changes the x coordinate by 3 points in the x positive direction and by 1 point in the or along the y-axis. So this will be the new parabola. Find out the equation of this parabola.
Is there a specific form it has to be in?
No formula as such. You have to, yeah, sorry.
Like a form, like vertex form, standard form.
No, you can choose any form, that's okay. I mean, I just need the equation.
So this is like a rough idea, but it would be like minus, and then in brackets, x minus 3 squared plus 1. I think it's like vertex form.
Okay, you will go in the vertex form and then try solving it. Okay, that could be a way to solve it, but I'll wait for everybody else to try solving it first. I'm just going with the assumption that everybody has understood the question at least. Anshu, Dhanushri, Nanya, Rehan,
Yeah.
give it a shot. So the only clue I would want to give you guys is, since I'm talking about moving the vertex, so the first attempt that you should make is convert this equation to vertex form. And then you can play around with this. I mean, once you convert them to vertex form, then your life becomes much easier. So that's why knowing the 3 different forms actually helps. Sarah, Neil, are you trying that? Okay. Shivatsav, are you will try? All right. So Vihan, I know you already started in the right direction, but just look at your solution and try completing that. I mean, you gave me the approach which was right. So try solving it and try forming the final equation and tell me what the equation would be. Okay. I'm waiting for 2 more of you to tell me the solution or the approach before I try giving it a shot. small correction, okay? Just keep this as x square, okay? Don't keep negative. I'm just trying to make it life little easier for you guys. Yes, sorry. That's okay. That's fine. So you got the question, right? I mean, the question is that I have an equation for a parabola which is y equals x squared plus 2x plus 3, and we are trying to move the parabola, the vertex of the parabola by 3 points in the positive x direction and 1 point in the positive y direction. So that means the parabola moves from here to here, and find out what will be the equation for this new parabola. No one is done yet. We are heading towards end of the class. We have 12 more minutes. Okay, so let's do one thing. I mean, I'll probably leave you guys a little early today because again, owing to the Christmas holidays, we don't want to make this class a very stressful class. Okay, so let's look at this. I would want everybody to pay attention to what I'm doing right now. I might not solve it to the end, but at least I'll bring it to a point where it becomes much easier for you guys to comprehend. And again, my approach might not look very methodical. I mean, as you would want it or as you would hear it from a teacher, but at least from a concept point of view, you'll not have anything missing here. First thing is, since we're trying to move the vertex, so I will convert this equation to vertex form first. So my equation is in standard form right now. So meaning I have to put something as something squared plus something or minus something, whatever it is. So x squared plus 2x plus 3. So I will say a plus b whole squared. So I will put this as x squared plus 2x plus 1. That makes it a complete x plus 1 whole square. And then the two remaining is what I will have. So I had 3. I just borrowed 1 from that, and that is what I am left with now. So my equation became y equals x plus 1 plus 2. So here you should look at this. What is the x coordinate of the current vertex? So the x coordinate of the vertex will be the lowest point, meaning this value has to be 0. Meaning x equals to minus 1. That is the situation when this will be minimum, right? So x is minus 1, and what is the value of y for the vertex? When this is 0, y is 2. So now look, visualize this way, okay? Now you have the vertex somewhere like x is minus 1, meaning here, and y is 2. So let's say your parabola is here. is lying like this. Okay? This was a vertex. Now what you are saying is, I want to move the vertex 3 points in the x direction. So your x coordinate will increase by 3. So this moves 3 points. So the x coordinate of the vertex will change from -1 to -1 plus 3, which will be 2. And then y coordinate I am saying move by 1 point upward in the positive direction. So earlier it was 2, so it becomes 2 plus 1, 3. So basically my vertex moves to this point here, and the coordinates of the vertex are 2, 3. Okay, so this will be a parabola. Now you have to find out the equation of this one. Now go back to this one. When you had this equation, the vertex form, your x was -1, it's here. Y was this, it's here. Same thing you can mimic here. Whatever is the value of x, just convert that into a reverse of it. Plus becomes minus, minus becomes plus. So here, value of x was -1, it was x plus 1. Now value of x has become 2. So it becomes x minus 2 square. So that was the change to the x. And now y. Y was 2 here. Whatever is the value of the constant, that's what is here now. Now it has changed from 2 to 3. So it will just change to 3. Same thing you can validate whether, if this is a new equation, will the vertex value be 2 and 3? You can verify that. Yes, it will be 2 because the vertex will be the lowest point, and that will be the x coordinate, the lowest point, the lowest value of y will be the case when this is 0. So x is 2 and y is 3. So this becomes a new equation. So this, now you can break it down. So it becomes x squared minus 4x plus 4 plus 3. So this becomes x squared minus 4x plus 7. So if you look at how much time I took for solving this one, by just referring to the vertex form, it was not that complicated. It's just about using a lot of what you call notes for doing rough sketch. When you draw things, right, when you do the rough work, when you draw things on the paper, whatever is your understanding, when you picturize that or visualize that, and then you try solving it, it becomes much easier. Did I do a lot of calculation? No, I did not. As soon as I got to know that I have to find out the vertex coordinate of the vertex, I just, first thing that clicked to me was convert to vertex form. That is when I'll be able to relate to the vertex, the current position versus the new position. And as soon as I converted that to vertex form, I was able to solve it in 2 to 3 minutes. So that is why now comes the most boring element of my teaching. This analysis part, the reading part, that is where we need to practice. When you read the question again and again and you analyze, you put your thoughts together, that is when Nike will come to your rescue towards the end. Don't jump onto solving a problem. So Vihan, when you told that, okay, I'll look at the vertex form, convert to vertex form, that gave me the clue that yes, at least you're thinking in the right direction. Meaning you're not jumping on to solve it. You are making a blueprint before you're trying to solve it. And that's the key. I would want you all to practice that. I was thinking that you all would be able to solve this in 5 minutes time. You guys took a little longer, maybe because I had probably assumed that since when I was putting this question, I had that blueprint in my mind, right? That's why it took me just 2 minutes to solve it. But you guys had to think on those similar lines before solving it, and so would be the case, right? When you appear in an exam, somebody who has set the question, he or she would have set the question with certain frame of mind. So you have to get to that frame of mind to see what is your fastest route for solving those problems. Okay? I know it's a lot of blabber. I'll stop here. Are you guys with me so far? Were you able to follow or understand what I did?
Yes.
was it easy to understand? That's more important even.
Yeah, after you explained it now it's really clear. Like, because I didn't know how to change the standard form to the vertex form. So like, I was trying to do it without doing that.
So that's my takeaway, right? When you guys learn something and I hear it from you guys, it makes me more relevant, right? So if I just teach, okay, I want to teach something, I'll teach and disappear. Nobody gets benefited. So thank you. I mean, I got my Christmas gift. Thank you. All right. How about everybody else? Do I have Christmas gift from everybody? Yes, Ananya.
Sorry, that was an accident. I meant to do a thumbs up.
Okay, so thumbs up is a Christmas gift, right? I mean that's why I was just checking, right? When you guys followed what I did, I mean, see, I'm not claiming that I'm a born star, but when I was trying to solve this, right, when I put this question, right, I was myself wondering that, okay, did I get the right question or will it be way too tough? But then when I started thinking about it, then I was very clear that, okay, it's not a big deal. So never think any question is being tough. It's just about knowing the concepts. If you guys know the 3 basic concepts or the 3 standard formula, 3 forms of a quadratic equation for a parabola, life is much easier. So with that note, I will let you guys go. Enjoy the rest of your evening. Have a great Christmas and New Year break. Convey my greetings and wishes to your family members as well. And see you guys next year. Yeah?
Thank you. Bye.
Alright, bye-bye. Take care. Yep, bye-bye.
Okay.
Bye-bye.
Bye.
Bye-bye. 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 Okay. Who had joined? Yeah, Diti. Bye, beta. Aryan, you can drop off. Hi, Diti. Can you hear me okay?
Yes, sir.
Okay, wonderful. Are you?
Bye, sir.
Bye, beta.